Hello, myself Dr. Anuj Purwar. Today we will discuss about the rural water supply. Criteria for source selection. While selecting a source of water for rural area, first priority should be given to a source which needs no treatment and pumping. If such water is not available, then detailed investigations should be done to select a source which requires minimum treatment. Geological investigation of the area should be carried out for estimation of yield. Sometimes information from local people is a good guide for the investigation. Information includes the history and performance of existing wells and flow estimate from nearby streams. Quality of water from existing wells may be analyzed. After getting information about the site and water yield, following alternatives may be tried in order of preference. Water which requires no treatment to meet bacteriological, physical, and chemical requirements and can be delivered to the consumer by gravity is in ideal condition of no pumping and no treatment and is the most economical, but it is mostly limited to the spring. Water requiring no treatment to meet physical, chemical and bacteriological requirement but to be pumped should be given second priority. Such condition is met from deep wells where water is drawn from the pumps. Water which requires simple treatment and delivery is through gravity system is to be given third priority. Water requiring simple treatment and to be delivered by pumping is the last alternative because this will be the most expensive. Water supply from surface sources are included in this category. After selecting the source, following points should be kept in mind for ensuring safe water to the consumers. First, collection system should not damage the quality of water. The treatment employed should be simple and economical. Around the source, a depth of 3 meters from ground should be made watertight to avoid pollution from contaminated surface water. Where public wells are provided, a special drainage system must be provided for used water. In case of springs, water should not be exposed to the atmosphere. While providing drinking water from well, septic tank, sewers, subsurface pits should be at least 15 meters away from the well. Soak pits and sewage disposal works must be located on the downward slope of the ground at least at a distance of 30 meters from the well or source. Assessment of water requirement. The assessment is based on requirement to be fulfilled and funds available. The requirement may be for individual houses, a particular area, or a whole locality. It should be considered that the supply is just for drinking water or for other necessities also for the in assessment. Following guidelines should be kept in mind while estimating water requirement. Capacity of one tap is around 10 liters per minute. So therefore quantity required is equal to number of taps into minutes of the supply. If houses are not having taps and water is being supplied only by street taps, then demand is the 18 liters per person per day. If house taps are available, then demand is 45 liters per person per day. Demand for a school may be 45 liters per head per day. For every 200 people, one tap is the must. Taps or water outlets should be such located that water carrying distance should not be more than 100 meters. Here the water requirement for rural water supply. Hand pumps capacity 40 liters per hour per day. Pipe supply including kitchen supply, this is the 75 liters per hour per day. Schools 45 liters per hour per day. Schools without pumping 25 liters per hour per day. Livestock like the horse, this is the 50 liters per animal per day. Dairy cow 70 liter per animal per day. Sheep 10 liter per animal per day. Chicken 100 for 100 members are there, then 20 liters per 100 animals per day. So total quantity should be calculated for 1.5 times the present population. Wells. It has been pointed out that subsoil water is best source of water supply for rural areas, and the most common and the popular source of groundwater are wells of one type of or another. A water well may be defined as a hole or shaft sunk into the earth crust to a depth below the free water level or into deep water bearing strata for the purpose of obtaining groundwater. There are following common types of wells: dug wells, driven wells, and drilled wells. Now dug wells. Here the picture for the dug wells, simple wells available, and how this is the oldest situation where we get the water from the well. As shown in figure, a hole of 1 meter to 3 meter in diameter is dug into the earth, usually manually, until a flow of water is obtained. The hole is then walled and covered to protect it from surface water. Depth of well varies depending upon flow of water below the ground surface. In some cases, it is even 50 to 20 meter deep. Driven well. A driven well is a small diameter well assembled by joining length of steel pipe with threaded couplings. Section of steel pipe is consisting of a screen. The screen allows groundwater to flow into the well while keeping the sand out. Since driven wells are usually constructed in permeable sandy soils with a high water table, they are susceptible to contamination from land use activities such as subsurface seepage system and heavy use of the fertilizers. However, if land use taken into consideration in the immediate area, driven wells can offer protection from most type of contaminants, especially bacteria. Here the picture for the driven wells, as we have discussed earlier. Drilled wells are constructed by percussion or rotatory drilling machine. In right side, this picture is shown. Drilled wells have a lower risk of contamination due to their depth and use of continuous casing. In most of the regions, a satisfactory source of water is obtained at a depth around 30 meters or less. But in rocky regions, sufficient water is available even at 100 meter depth. Lifting of water. First, it was just taken out of the well, pulling water filled bucket with hand. Later on, some lever system was applied, which proved to be convenient. So here we see the lever system. A person how he used the wooden planks or stamps for the purpose of the as a column and the lever. Pulley system also help in reduction of effort in the lifting water. So we use the pulling system. Here this is the picture. Here subsequently bucket pump was this is the bucket pump. Subsequently bucket pump was evolved, in which a small bucket attached to an endless chain is rotated so that each bucket dips into water and gets filled up, carries water to the top and empties it. So this in picture we are seeing the this is the chain is moving and attached bucket is filled and then this is emptied. Lift pump. Lift water up from the source by suction. The pump reduces the atmospheric pressure on the water in the suction pipe and the atmospheric pressure on the water outside of the suction pipe pushes water up into the pump. Lift pumps are used for lifting water from lesser depths and are also classified as shallow well pumps. Following figure shows the full assembly of a lift pump, which is commonly used in the rural water supply. So in this lift pump, I'm starting from the upper height. This is the handle. Then a rod is attached with the lower cylinder, from which the lower cylinder is attached, and there is casing and the pump cylinder. Then here the suction pipe is available. First the pump is primed, putting water from the top, and the plunger is raised. This is the position of the A. This is shown in the figure right side. Due to presence of water, air does not pass the plunger, hence a part of the atmospheric pressure is lifted off the water in the pipe. Air and water in the pipe follow the plunger upward. Now, the space in the cylinder below the plunger is filled with air from the pipe. At the top of the cylinder, below the plunger stops, and the check valve closes due to its own weight, and the air in the cylinder is thus entrapped. Now position B, shown in the figure. When there is downward stroke, air is compressed between the plunger and the bottom of the cylinder. When the pressure becomes greater than the atmospheric pressure above the plunger plus the weight of the valve, the air lifts the valve and escapes through the priming water, as shown in the figure B. Now figure C. Now situation C. On the next upstroke, more air is drawn out of the pipe and water rises higher, finally flowing into the cylinder under the plunger. When the cylinder and pipe gets filled up with water, as shown in figure, the check valve closes and the water is entrapped in the cylinder. Now situation D and E. On the next downward stroke, the plunger and valve pass through water, as shown in figure D. When plunger reaches at the bottom, the cylinder plunger valve closes and water is trapped above the plunger, as shown in figure E. Now figure F. On the next upward stroke, water above the plunger is lifted out of the pump, and at the same time water is drawn into the cylinder through the check valve. On each successive stroke, step E is repeated, and on each successive stroke, step F is repeated. Thus the pump delivers water at each stroke. Force pump. This is shown in that figure, in that figure. The principle of operation of a force pump is the same as that of single acting plunger type of lift pump, except that it is enclosed at the top and hence is used to force the water to higher elevation or against the pressure. Protection from contamination. Protective as well as prevention measures should be taken to keep the water free from contamination. For annual water supply, groundwater is always preferred because it gets natural filtration while percolating into the groundwater. Since groundwater is taken out of the wells, hence care should be taken to prevent the well water from the contamination. Following care should be taken to safeguard the well. The well should be covered with watertight cover. The lining inside well should extend around a meter below normal water table. Sewers and other polluting sources should be kept at least 50 meters away from wells or source of subsoil water. The well should be drilled to a greater depth. In place of lifting water with buckets, hand pumps should be provided, which protect contamination to a greater extent. Wherever financially viable, deep wells should be provided with pumps and in a tank get a household supply. Contamination of subsurface source is due to various minerals matter that is being added during the course of percolation. Hence, percolation of minerals from effluents of industries should be prevented. So this is all about the rural water supply. Thank you.